Hi, welcome to my video on the addition formula for sine and cosine. This one is number 3, and in this one we're going to find the exact values. Expressed as the sum of two angles such that each angle has a reference angle belonging to the special right triangles. What I mean by that, the reference angle of the special right triangles. Well, if we take the special right triangles are 30, 60, and 90. And also, the special right triangle is 45, 45, right triangle. So we need these angles here to be expressed as the sum of these. So 105 could be 60 plus 45. And 60 is right here and 45 here during the special right triangles. We could also do 150 minus 45, and that will give you 105. 45 is special, and 150 is in the second quadrant with a reference angle of 30. Now, how about 165? 165 could be 120 plus 45. Notice that all of these angles are so far ending in a 5. So 120 plus 45 is 165. Or we could have 210 minus 45. 210 minus 45 is 165. 120 again is in the second quadrant with a reference angle of 60. 210 is in the third quadrant with a reference angle of 30. Now, what about 285? 285 could be a 240 plus 45. And a 240 is in the third quadrant, rotating around with a reference angle of 60. There's the 45. Or it could be 330 degrees minus 45. If you subtract that, you get a 285. And again, 330 is in the fourth quadrant with a reference angle of 30. Now, 210. Let's see what 210. 210 can be, I think of 180 plus 30. And 180 is a special angle, which we can do the sine and cos of, with the reference angle of 30. Or we could have 150 plus 60, and that's 210, and the reference 150 got a reference angle in the second quadrant of 30. Or we could have, there are many answers here, I'm just doing a few of them. We could have 240 minus 30, or we could have 120 plus 90. So there's many addition. You can add up each of these pairs of angles and get 210. Now let's work out some of these. Why am I doing this? Well, find the exact value of each. Now if I take the calculator and do the sine of 75, if I take the calculator, well, first of all, I'll turn it on, clear. If I do the sine of 75 degrees, notice this decimal 9659258. That's irrational, and that's not exact. That's an approximate. But we want the exact answer. That means we're probably going to have to answer out in terms of radicals. So the sine of 75 is 75. What I think about, it's a 45 plus 30. So this is the sine of the sum of two angles. So that's sine. That's the sine, cos, sine. And the angles are 45, 30, 45, 30. And these are changed. So with a sine, whatever you do with sine, whatever's here stays here. So sine, that's a plus, that's a plus. These are changed, so the addition stays addition. Now we got a 45 and a 30. So these are the special right triangles. So if you draw these, and we draw the rotation of 45 degrees right here. This angle is 45. That rotation is 45. This is 45. This is 90. That's 1, 1, root 2. X is positive, Y is positive, and hypotenuse is always positive. So the sine of 45 is 1 over root 2. So we multiply by root 2 over root 2. We get root 2 over 2. So sine of 45 is root 2 over 2. The cos of 45, cos is the adjacent over the hypotenuse, 1 over root 2. So that's also root 2 over 2. Now we deal with a special right triangle which has the 30 in it. So let's draw a triangle. Do a rotation of 30 right there. Draw the terminal arm, set up the right angle. So that's a 30, that's a 60. So this is a 1, this is a root 3, and this is a 2. And it's in the first quadrant, so everything is positive. So cos is the adjacent over the hypotenuse. So the adjacent is root 3 over 2. Adjacent over hypotenuse. And the sine of 30 is opposite over hypotenuse, which is 1 over 2. So we multiply that, we get root 2 times root 3 is root 6 over 4 plus root 2 over 4. So that gives us root 6 plus root 2 over 4. That's the exact answer. And then if you take this and change it to a decimal on your calculator, you will get the same answer. So root 6 plus root 2 divided by 4 is the exact answer for the sine of 75. Okay, what about the exact value for the cos of 15? So the cos of 15 is the cos of, and we can do a 60 minus 45, or we can do a 45 minus 30. So that's cos, sine, sine. So that's the cos of 45, 30, sine of 45, 30, and the cos, the minus becomes a plus. So again, using these up here, same triangles, the cos of 45, there's the 45 is 1 over root 2, which is root 2 over 2. The sine of 45 is 1 over root 2, which is root 2 over 2. The cos of 30 is root 3 over 2, cos adjacent over the hypotenuse. And the sine of 30 is 1/2. We have the addition, multiply, we get root 6 over 4 plus root 2 over 4. So that's root 6 plus root 2 over 4. Notice that these two answers are the same, and it makes sense because if you think about it, if you draw a circle, and you do this, and you set up a right triangle, so if this rotation here is 75, this is a right angle. This angle is 75, and this angle here is 15. So if you make this, whatever it is, let's call this value x, let's make this value y, and let's make this a 1. And so therefore, if you, the sine of 75, the sine of 75 is in this triangle. The sine of 75 is opposite over hypotenuse, which is the y. And the cos of 15 is the 15 is here. Cos of 15 is the adjacent over the hypotenuse, which is the y. So these two answers come out to be the same, and I'm trying to show you why. But even if you convert these, you should get the same answer on a calculator. They're both the same answer. So the sine of 75 and the cos of 15, let's check we should get the same answer. Turn on the calculator. So the sine of 75 is 9659, and the cos of 15, 9659. So the two of them are the same. But using the calculator, you can get the decimal, or this is the exact value. And here's another reason why these are the same. And let's continue. What about the sine of 345? Well, we need the addition or the subtraction of some angles. So 345 is 135 plus 210. 135 plus 210. So add them up and you get 345. Now let's work out each of these. I'll draw them down here. And here's the circle. 335 degrees is approximately right here. There's the terminal arm. And if that's 135, then this angle here is 180, so this is a 45. So we got a 45 right triangle. And this is a 1, that's a 1, and that's a root 2. Because this is in the second quadrant, the x is negative and the y is positive. Now let's draw 210. 210 on this circle goes around here. 210 is approximately right here. There's 210 rotation. There's the terminal arm coming out, perpendicular to the x-axis. So that's a 210, that's 180, and this is 30. So this is 30 here, and this is 60. So opposite 30 is a 1, opposite 60 is a root 3, hypotenuse is a 2. And the x is negative, the y is negative, and hypotenuse is positive. So we have all that done. Now let's write what this one is. Sine is sine, cos, sine. And we got 135 degrees, 210 degrees, 135 degrees, 210 degrees, and the sine is plus stays as a plus. Again, these are rotated, switched, so the additions and minuses are not switched. So what is the sine of 135? Let's use this one. The sine of 135 is, sine is opposite over hypotenuse. That's 1 over root 2. So that's root 2 over 2. The cos of 135, cos is adjacent over hypotenuse, is a negative 1 over root 2, which is a negative root 2 over 2. We got 210. The cos of 210 is the cos of this 30. Cos is the adjacent over the hypotenuse, so it's a negative root 3 over 2. And the sine of 210 is the sine of 30, opposite over hypotenuse, which is negative a half. And we simplify that. That gives us a negative root 6 over 4. And we multiply negative to a negative positive, so it's a positive root 2 over 4. And the answer is negative root 6 plus root 2 over 4. Notice we can't, again, I'm assuming that you know you can't add these radicals because they're not the same. So that's the exact value. And if you convert this to a decimal and did the sine of 345 as a decimal, you should have the same answer. Now, D, one more. We got cos, sine, sine. So cos, sine, sine is the cos of pi over 6 and pi over 12. Pi over 6 is the first one. Pi over 12 is the second one on each. And a cos is related. These didn't change, but you change the sign, so that becomes a plus. So this is the cos. We have to add these. So that's the 12 denominator, common denominator. So we multiply by 2 over 2, so that's 2 pi multiplied by 2 over 2. 2 times pi is 2 pi, 2 times 6 is 12. Now we have a common denominator, so we have 12 is the denominator, 2 pi plus 1 pi is 3 pi. and that reduces 12. 3 into 12 goes 4. And if you think about it, let's change it to pi over 4 is pi over 4. Pi is 180 divided by 4, so that's a 45. And the sine of 45, just look back up here, and we got a 45-degree angle again. Here's terminal arm. There's a rotation of 45. This is 45, 45, 1, 1, root 2. And the cos of 45 is adjacent over the hypotenuse, which is 1 over root 2, multiplied by root 2 over root 2. So we get root 2 over 2. And that's the exact value. Notice I had radians here, but when I deal with radians, I like to change my radians to degrees because it's easier to draw the circle and know the special right triangles in 30, 60, 90, and 45. So that brings us to the end to this video. And if you do like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.